Welcome along to another lesson with Mr. Burns. We're going to look at the straight line and looking at parallel lines in particular. You may have seen this presentation already without the audio, and that's us starting to add the audio to it. Okay, so we are going to, by the end of this lesson, this presentation, we're going to show that maybe lines like y minus 2x equals 0 and 4y plus 20 is equal to 8x. So you may have had some experience already with parallel lines at National 5 if you're doing higher, but this might also be brand new to you at National 5. So a small starter activity just to engage some of your prior learning. Now, these activities should all be able to be found in the previous videos if you want to pause the video and have a go at them. Okay, let me talk you through question 1 then. Describe the following straight lines in terms of its gradient and y-intercept. Now, I've been very particular on those the language there. The gradient, okay, and I've chosen y equals x plus 4, particularly because there's a misconception with that x on its own having a gradient of 0. Now, you should know that the coefficient of x, so the number that multiplies the x, is the gradient, and something multiplied by 1 is still the same thing. So y equals 1x plus 4. If you wrote the 1 in there, you would probably write down gradient 1, y-intercept 4 without even thinking, but the fact that it's not there makes people think that it's 0. Now question 2, describe this linear graph in terms of its gradient and y-intercept. Okay, now common question, you should be able to look at something and write down a possibility, right? Write down and use your knowledge of a possibility and then think, well, is that true? What would I have to do to make it true? Now you'll notice that this graph does not intersect any coordinate point like 1, 1 or 2, 2 or 3, 3 or 4, 4. Right, I've chosen this particularly to try and get you to think about what the possibilities may be. Now you have by inspection, you'll have a very good idea of what that y-intercept is. My initial would be 3, right? The gradient, well, it's definitely going down, so it's negative. What kind of angle is it going down at? A gradient of 1 is 45 degrees. Okay, is this a 45 degrees going down the way? So the angle from the positive direction of the x-axis here, is that 90 degrees plus another 45? Is that 130 degrees to the x-axis? Okay, so if you had a particular number to choose, would you choose -1? Would you choose -2? Would you choose -3? Would you choose -1.1? Would you choose -1.2? Would you choose -1.01? Okay, that's the other possibilities that may be. Okay, and this would be a discussion you would have. You should have questions about question 2. Does it intersect at 3? Does it intersect at 2.985? Does it intersect at 3.1? Okay, so there's loads of possibilities there for you to have a thinking question, right? Unless you do the maths, then you will not get an exact answer, right? You'll not get exactly what you're looking for. A couple of activities there just to get you thinking. So parallel lines themselves, they are equidistant from each other. So if you've got two lines, if you take two pencils or two rulers and you make them equal distance from each other, then they are said to be parallel. Okay, now you will also know that parallel lines never meet. In some examples you maybe think about are maybe like train tracks and maybe curbs on roads. Okay, so what you have to really engage with is the fact that they're equidistant, right, and that they will never meet. Okay, they've also got equal gradient, they've got equal steepness, right? And then what I've said there is that you denote the equal sign with that equal sign, right? Just to remind you that that has to be there, okay? There's a wee note at the bottom saying that straight line is not a curve. A straight line is a straight line. Okay, so I've got some examples of parallel lines, right? And the best way, right, to do this quickly and most efficiently is to use a graphics package like Desmos. Right, so go into desmos.com and then just start graphing, enter in those equations, so y equals 2x, alright, and I've just screen grabbed them from Desmos, right, that's why you don't see the axes labelled. So y equals 2x and y equals 2x plus 1. Now what I've said at the bottom is it's too difficult to notice that they are the same gradient unless they are on the same graph. Now, by inspection, by looking at it, if you stand further away, you can probably see that they are the same steepness. Okay, but look at the scaling of it, right? Look at the scaling of the step and the axes. Okay, so there's a scaling of 1 on the right hand side, there's a scaling of 2. So the scaling isn't exactly the same. Okay, would that change it? Right? We always question everything. So we've got y equals 2x and y equals 2x plus 1 drawn on the same graph here to show that they are equal distance from each other. Okay. Now, this presentation, this exercise is all about doing this through a table of values. There are other methods. This is a first lesson. Okay. And you should be thinking about, well, have I watched that video? Have I done this already? Do I know how to do it? How can I graph each of these questions? So see, each of them are different. So you can pause the video and have a go. If you're not sure about it, then please make sure that you are watching that video. Okay, the Australian producing a table of values for a given linear equation. It's the first one, y equals 3x and y equals 2x plus 3. So you might already have an idea about that. If you don't, please do a table of values and see that those ones are parallel. Right, as with question 2, what do you notice about question 2? It's the same or different from question 1. Question 3, again, what is the same and what is different? And question 4, what is the same and what is different? So do each of them on a table of values, right? And then go to Desmos and input each of them on to see if you are correct, right? That's a good way of checking. You've got these advanced graphics packages online now like Desmos or GeoGebra that will really help your understanding. Okay, so I've said there just to check using Desmos, and the solutions are there. Okay. Now, question 1. What's the same and what's different? So you've got y equals 3x and y equals 2 plus 3x. We said that the general equation of a straight line was y equals mx plus c. And this is written as c plus mx. So I would encourage you, right, to write this as y equals mx plus c, right, 3x plus 2. Okay, so the left hand side is still equal to the right hand side. So these gradients are the same. Yes. Question 2, what is the same and what's different? Okay, so this is similar to this in the sense that the way that it's written, right, it's got a y-intercept positive, it's got a positive gradient. What do you notice about them? Did you do that one? What did you notice? Are they parallel? Well, of course they are the same line. Okay, they are parallel. They are the same distance away from each other. There's no distance. Question 3. What's different about this in comparison to the other two? 2y equals 8x plus 4. Now, at the start, we were saying that, and always, y equals mx plus c. So get it into that form. Divide each of these terms by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 4 divided by 2 is 2. These are the same equations. Okay, they will give you the same result. They are the same straight line. They are parallel because they are the same. The distance between them is 0. And the last one, which I apologise, is different. So made a mistake there. So let's have a wee look back at this, because these are the ones that I was looking to do with you. So 12x equals 4y plus 8, 12x equals 3y plus 15. What's the same and what's different? They are definitely not of the form y equals mx plus c. Right, they are of the form mx equals y plus c. We've got a 4y there. So rearranging each of them, okay, so what can we do? We can change the side, invert the operation, or because the left hand side is equal to the right hand side, then the right hand side is equal to the left hand side. So 4y plus 8 equals 12x minus your 8 divided by 4. Okay, so if this value here has been divided by 4, and this value here has been divided by 3, the gradients are not the same, therefore they are not parallel. Okay, now have a wee go at that question, although it wasn't the particular question I wanted to ask for this run of questions, but you'll also see that these are not parallel for that reason. This is actually simpler than the other one we just spoke about, because that gradient would be 3, this gradient would be 4, therefore not parallel, right? The gradients are not the same. Okay, so I've kind of answered those questions at the bottom. What is interesting about question 2 and 3, right? Write down your learning from this exercise. It's important to reflect after you do an activity in maths and not just do it procedurally and getting through the exercise and that's it, ticked off, and then checking your answers. It's important to understand it, right? Maths is all about making connections to things that you've learned before that will help you for later on. Okay, now what other questions could lead to misconceptions? Write them in the comments below, so I'll let you have a think about that. Right, this is one in particular. Okay, 12x. Oh look, the 12 is the same. So mx, the gradient's 12. Oh, but hold on, there's multipliers on the y, so that's one common misconception. So why don't you have a think about other ones, and please question everything that you do. Okay, so that was a question from the objective page, and with each of these, make sure you understand the starting point, the table of values, know that Desmos is there or GeoGebra is there. Can you marshal the facts by inspection? Could you look at these and say, oh, if I rearrange that equation, what would I get if it was y equals mx plus c? What about that one? Are they the same? What's the same? What's different? What other methods could you use? Have a think about that. What other algebraic methods could you use? So we've talked there about changing the subject around. So what other algebraic methods could you also use? Okay, now just a wee encouragement just to like and subscribe, and please make some comments.